So hello and welcome to the Festival of Computing for 2021, our collaboration between Plymouth University and Computing at Schools. And so welcome to the session with David Walker, a lecturer here at Plymouth University, works with me, poor chap. And so he's going to be doing the course, the session today. Before we get going, there's a couple of things I do need to say. In terms of housekeeping, can you please keep yourselves muted and use the chat window if you've got questions. You should be able to find the chat using the icon at the bottom, and it may appear on the right-hand side of your screen, depending on how that's all set up. If you tweet, please tweet. The hashtag is CASPLYM21. Okay. So, with no further ado, I'm handing over to David. There you go.
Thank you very much, Shirley. So, good afternoon, actually. I'm 2 minutes behind the times. And thank you for coming to this session this afternoon. So, I'm going to spend about 40 minutes talking about artificial intelligence. And AI is, I think, one of the most fascinating areas of computing. Obviously, I'm biased. I work in AI. But my hope is that I can talk about why I'm passionate about that and some of the exciting opportunities that are present in AI. So I've got some examples, some problem areas that we work on at Plymouth, and my plan is to talk through those this morning with you. So let's move on. I think the first thing that we ought to do is probably start with a definition, because AI is one of those things that people know notionally about. If you're not a computing person, or if you're you're working in another part of computing, then you will know what AI is. You've probably heard the term. You may associate it with science fiction films. And in order to properly engage with that, I think it's useful to sort of all be on the same page. So I like to start with this definition. And the first thing that people say when I do this is say, well, this is 1983. This is a really old definition. The term artificial intelligence actually goes back to 1956, when it was coined at a workshop in Dartmouth in the United States. And it was invented by a group of academics who sat down and said, let's make a machine that can think. Let's come up with a thinking machine. And they gave themselves 10 weeks to do it. And so that'll be plenty of time when we'll have this cracked by the end of the session. And all they actually really did was, well, they did two things. They defined a set of subproblems that would need to be solved before we could have an intelligent computer, and they came up with the name. So that was their 10-week workshop. The definition of AI has rumbled on for various years, but I like this one from Elaine Rich in 1983. AI is the study of how to make computers do things at which at the moment humans are better. And I think that is a very, very high level but succinct and accurate way of describing what we're trying to do. We want to come up with software, hardware that interacts and in some way fulfills the requirement of being intelligent. And often that's a very subjective thing. We'll talk a little bit later about how to tell if you've got an AI. But that's basically the idea of what we're looking for. We're looking for something that is software, hardware, and can think like we think, and do things at least as well as, if not better than we can do, beyond the sort of standard number crunching, information retrieval, things that computers are excellent at doing. So we have a lot of AI, I think, is something to open with. At the moment, in 2021, a lot of our lives are involving AI, and I think that's true of all of us, because there will be AI controlling the call that we're having now. There'll be AI built into the Zoom software. There'll be AI involved in the routing and the security of the network connection that's bringing me to all of your computer screens. And that's something that we work on at Plymouth. Outside of that sort of realm, AI is very common. So we have robotics, for example. You've got the robot person on the screen there. And robots are sort of the classic AI thing, really. I think people, when they think of AI, they think of robots, and you think of the Terminator, perhaps from the Terminator films, and HAL from 2001: A Space Odyssey, and Mr. Data from the Star Trek franchise. And you have science fiction, they're not doing us any favors as AI practitioners, because actually what they're doing is making the general public think that this is all really straightforward, and it makes it look a lot easier than it is. However, robotics are really useful. So you have there are many ways in which they're very useful. And I won't go into all of them here, but things like fine motor control, robotics used in healthcare for surgery, for example. If you have a very fiddly piece of surgery to do, using a robot to do it can give you that extra level of precision that as the patient you would want. Accessing areas that are dangerous to inhabit. Actually, there was a program on last night that I haven't watched yet about Chernobyl. So areas that are highly radioactive, it's not safe to send humans into. We can send robots safely in there. So if there's an emergency situation at a nuclear reactor, for example, then perhaps deploying a robot is a sensible way forward rather than risking human life. I've mentioned healthcare. The next image on the right, so I'm looking at these images here. This one here is representing health data. Recently, there's been a lot about analysing health data in the press, and we've had daily press conferences where people have been presenting data and information based on that data, and a lot of that analysis is being done with AI. So modelling and using AI in a way that's not typically, robotics facing or producing human-like intelligence, but it's AI. It's still a branch of intelligence trying to find patterns in that data. We have self-driving cars and navigation systems. We'll talk about those a little bit later. But navigation is one of the sort of early adopters, in that you have sat-navs on your phone, you have TomToms type things, other brands are available in your car, and they'll plot you an intelligent route. And if that route changes, so if, for example, there's a traffic jam appears while you're en route, they'll adjust and they'll work out the best way for you. And that's all done with AI. Some of you may have heard of recommender systems earlier on. So Netflix was a very early adopter of this type of technology, and they have a recommender system. So something that recommends you what movies you might like to stream based on your preferences. And one of the things they did in about 15 years ago now, about the early mid to late 2000s, was to have a prize, and they offered a substantial financial prize, I think $1 million or something from memory, for the software engineering team who could improve their recommender system by a certain amount. So that's a use of AI. It's a nice lucrative use of AI for one of the teams, which 3 years after the competition was launched were able to win that prize. Facebook and Twitter, so social media of all kinds, they all use AI in that way to recommend you topics you might be interested in, people you might like to connect with, and that's all AI under the hood there. Facebook uses AI extensively in your image library. So if you upload an image to Facebook and tag someone in it, it will then use AI to try and identify anyone else that's in the picture, and it does that really well, I think. You can make an absolute fortune if you can use AI on the stock market. So I have a project student at the moment who's looking at modeling financial data and predicting whether when's the best time to make stock trades and that kind of thing. So there's a lucrative side to it there as well. And then we have on the right hand side these home assistants that have cropped up. So in the last 6 or 7 years, we've had various home assistants. We have Google Home and the Amazon Echo on the screen, and they use AI in the way they understand what we're saying and then translate that into an action. Depending on how good your home assistant is, you may have a slightly unfavorable view of how good AI is. Certainly my Alexa sometimes needs told 3 or 4 times. But these are all ways that AI has infiltrated our daily lives and in some cases made it better. It's entirely open for debate, I think, on how often that's the case. So what we're basically looking is, if we have the goal of having general artificial intelligence, something that that walks, talks, and thinks and behaves like we do, then we're thinking largely about modeling the human brain. So the human brain is what characterizes us. It's what makes us who we are. It's what enables us to think and understand our environment and behave and act. It does that by receiving inputs from our senses. So at the moment you're watching and listening to me. So your eyes are receiving light from your computer screens, and that light information is being transmitted to your brain. Your ears are picking up the digitized version of my voice, and that's coming into your ears and going through into your brain as well as signals. And your brain is processing all of this data. Something else that we're very good at doing is processing the information and then making decisions based on it. So we make decisions. You make decisions throughout your life and you don't think about it. But it's something very difficult for a computer to do. It doesn't have the ability to make decisions in the same way as we do. Part of that's because we learn from our experience and we have a powerful memory. So if you are watching now, you'll have the memory of watching this webinar, and you'll go away and you'll probably remember some of the detail that I talk about. At some point you may watch a Netflix film or something like that, and that might trigger your memory, and despite the fact that you haven't been thinking about what I said about Netflix consistently, and there's been a gap in engaging with that sort of knowledge, when you come back to Netflix, it'll remind you of what I said. And that's something that the brain does, accesses information very efficiently, and it can access relevant information. You're not going to be thinking about AI when you're using Netflix, but the reminder will be there. So that's the human brain. That's what we're trying to reproduce. What we're working with are computers. So we have computers that are programmed to process data in a predetermined way. So we give them some software and they run and do something with that software, execute some instructions. So we have some source code here. This is some JavaScript that I've written, and that will execute in a certain way. So that's accessing a resource on a web server and returning the result to a web page. And it will always do that repeatedly. As long as everything's there and the web server is active, then that will run. What it won't do is think, I wonder if David would also like this piece of information, I'll go off and get it. It doesn't have that autonomy. It does have the sort of input signals that we're after. So it has cameras, microphones, other sources of information such as the internet, but it can't think for itself. It can process that information as we've told it to, but it can't autonomously decide what to do with it. And that's what we're after. We're after something that can process data and can sort of essentially think for itself. So we're after something that can teach machines to learn from experience. And if I think about a typical type of thing, tagging photos on Facebook, I've already mentioned. Object recognition in images is a big problem for AI. Actually, it's one that's sort of been almost solved. I'm a little bit reluctant to say that it has been solved, because when we work on problems like that in AI, we work on specific bits of them. But the process of looking at a given image and spotting something in that image. So if I have a picture of a road with a large red vehicle on it in London, I might expect that my AI will say that's a bus. And that's sort of, we know how to do that. It's learned from experience. So the AI has been trained by looking at images, looking at, in this case, many thousands of images of buses would be required to teach it how to do that. We want it to be able to problem solve, humans problem solve. So for example, if I say to you, what's the best route to go from Plymouth to Exeter, then you would be able to probably look at a map, maybe ask Google, and you'd acquire some information, and then you could provide me with an answer. We want to be able to understand natural language. So I've given this talk before, and it forms part of a lecture that I give here at Plymouth as well. And despite the fact I'm working off the same slides and I'm using the same information, I never say the same thing twice. So the meaning is the same, and the the take-home messages are the same and the learning experience is the same, but the literal words that I speak will be different every time I do this talk. And that's because that's a human aspect of how we communicate. You don't use such a precise level of English that you always say the same thing. I could read off a script, but that would be incredibly dull and would have you all asleep, and that's not the aim. So we need a computer that can understand that. If I say to a computer, I'm in Exeter, how do I get to Plymouth? Or how do I get to Plymouth from Exeter? Or tell me how to travel from Exeter to Plymouth, then I want the computer to be able to understand all three of those things in the same query and to act accordingly and give me the information. That's incredibly hard. We want it to be able to have a role in decision making. So I've got make or support decisions for us on the slide here. And I think this is a really important difference. So if you think about computer-based decision making, the computer is making the decision for you. We're using some sort of AI, some sort of tool that we've developed, and it's making that decision for us. And sometimes, if I'm saying, find me a route from Plymouth to Exeter, I don't really care. I just want to get there. And there's no real issue with how it does that. If I'm saying that, for example, say I'm a judge in a courtroom and I'm saying, is this person in front of me guilty or not guilty? Should they receive this sentence or that sentence? Suddenly the distinction between making and supporting decisions becomes really massive. So I don't think, so I have this debate with my students, and we often come around to the idea that it's okay to support a decision, but usually it's a fairly unanimous statement that we don't want them making the decision for us. We don't want the computer or the AI saying this person should go to prison for 20 years. So the idea of having a human person that uses information provided by AI to support a decision is one thing. Making that decision and taking the human out of the loop is an entirely different matter, and is quite a big topic. We need to ensure that we're representing knowledge so that a computer can understand it and use it. So we can stick everything into a database if we want to, and we are very good in computing at having databases that will store information and getting it out again. The trick for the AI is working out which bit of data it wants and why. And in the way I mentioned earlier on, making those connections as we make as humans, and linking concepts together that perhaps on the face of it don't actually relate. So there's a lot here that we need to work on. So here's a natural language processing example. So I have two statements here. Well, I have one statement with two meanings. The statement is John saw Mary with a telescope. And there are at least two ways that this could be interpreted. It could mean that we have a person called John, a person called Mary, and by looking through his telescope, John was able to spot Mary off in the distance somewhere. It could mean that Mary owns the telescope and that John was walking down the street and he saw her walking along with her telescope off to look at the stars somewhere, or something like that. So we have one sentence there, perfectly reasonable sentence, but two completely different interpretations of it. In order to understand which one of those it is, and in order for us to use that as useful information, we need context. Specifically, we need to understand who owns the telescope in this case, and that will give us a good hint as to which way around it is. The computer will find it very difficult to extract that context, and one of the things that we need to do is enable it to do so. Sentiment is another important challenge for computers. So if you think about when you're saying something, my favorite example of this is, because of my age, I think, the word bad. So people who are my age or above tend to think of the word bad as being something terrible has happened. I'm feeling poorly today, oh, that's bad. People who are much younger than I am use the word bad to mean good, which for people my age or above can sometimes be confusing. For a computer, it can be impossible to understand because it doesn't get the real sentiment behind what the person's saying. Something that a computer will struggle to understand is sarcasm. So until we have basically a sarcasm detector built in, it's not going to understand anything I say because I'm a deeply sarcastic person. It will just take the literal meaning. So we have this idea of sentiment analysis, which is an AI tool to try and identify what the true meaning behind what someone's saying is. Here's another example. So computer vision, we've talked about already, and I've talked a little bit about identifying objects. This is something that humans do very well. You know, we're very used to, I'm sitting here in a room, I have a desk, a laptop, a monitor in front of me. There's a distressingly empty coffee cup on the desk, a phone, a notebook, and my brain can process all of this, and it can identify, yes, these are the objects that are in this particular field of view. Computers find this very hard, and that's because they're not dealing with objects, they're thinking in pixels. If you look at the picture on the right there, there is in fact a Dalmatian in the picture. And when I first saw this picture, I have to say I looked at a completely different part to where the dog is. So if I show you, if you follow my mouse, this is the back of the dog, that's its head there sniffing something on the ground. We've got a leg coming down, and then another leg here and a leg here. So this is, oh, sorry. One thing we haven't yet worked out to do is how not to advance the slide. This is an example of object detection. So I'm looking at this picture, and my brain is grouping together the markings on the screen so that that's a Dalmatian. I actually thought it was some, on the left, I thought it was a big view of its head when I first saw this and got it completely wrong. So we have that ability ourselves to do it. That's hard for a computer to do. What we're basically asking the computer to do is the sort of computational equivalent of looking at the sky and seeing something in a cloud. It's that sort of idea. There's a shape there, and we want the computer to do it. Object detection is something that's pretty straightforward for AI to do now. We have deep neural networks, and they're very good at doing that sort of processing. And object identification is also fairly doable, but that's a very narrow part of computer vision. So you want to be able to track, if you're using video, you want to be able to do all sorts of analysis, and there's a lot going into. So if you use PowerPoint and you put a picture in for accessibility, PowerPoint will put a caption on your picture so that if someone can't see the screen, they can get a text description of it. And it's using AI to do that. So very often you'll find you have to overwrite the caption with something more meaningful. But actually, it's a pretty good starting point. So that's something that it's working, coming out more and more. Another example of AI in the real world is self-driving cars, and we're talking here about cars that can get from A to B with no control, rather than the sort of cars that will do a bit and then you can still take control if you have to. So in the schematic I have on the top right, you've got there two people sitting in a car. It's driving down the road, and they aren't driving. They are sitting there, in a slightly uncomfortable looking position. You have to wonder what will happen if they crash because they're not sitting up properly. But they're not having to interact with the car. It's driving them from A to B. To do this, we need systems that can navigate, to be able to understand the environment, spot hazards. So if you think about spotting someone stepping off the curb, and there's an autonomous car coming, the car has to stop. There's no sort of oh well, it's the person's fault for stepping off the pavement. The car has to take account of that. There are schools of thought that this could actually be safer. So if you have, in the extreme, all autonomous cars on the road, then all the cars are doing the same thing, and road safety would theoretically go up. There'd be better transport options for people who can't drive, so people who are blind, children who are not legally allowed to drive, elderly people, and the social mobility that would give them would be, life-changing in some cases. The bottom picture is a Google autonomous car, and there is someone in the driving seat because at the moment they're not allowed to not be in the driving seat, but that is a Google autonomous car, so that car can drive itself. So these things are on the road, and they are coming to a main road near you soon, I think. So the government wanted them on the road in 2021. That was its initial stated goal. Obviously, things have happened since then, and they've had their attention focused elsewhere. And a lot of the challenge, the technology's there. We've got the cars doing the stuff that they need to do. A lot of the challenge, I think, is the legislative side. So getting the laws that will cope with autonomous driving. But I think this is something that's coming very soon, and this is a part of AI that may well revolutionize our lives very soon. So I've talked a lot about developing AI, and how will we know if we actually have one? This is Alan Matheson Turing, and he is one of the fathers of computer science. He's one of the real originators of the field, and he actually had an impact in many different parts of computing. He defined the first one of the first theoretical models of a computer before he could build it. So he defined Turing machines, which are a model of a computer. That's an entirely different talk, but he had such a great impact. In the area of AI, his impact was to propose what's called the Turing Test. And the Turing Test is based on the idea that you have a human person, and they're having two conversations. They're having the same conversation with two other entities. One of them is a human being, another human being, and one of them's a computer. But the conversation is being held anonymously. So the person who's running the test is passing messages. They can't see which is the human and which is the AI. And the aim is for them, based on the responses alone, to detect, yep, that's the AI, that's the human. And the idea is, if you can't tell the difference, then the computer program that you're talking to is intelligent. So this was defined in the very early 1950s. So this was before there was the term AI, for one thing. The Turing test is probably not applicable it was written down in very specific ways. There were very specific levels of I think it had to convince 30% of the judges or something like that. And they're very specific rules based on the understanding at the time. Things have changed, and we have much more widespread ways of testing now. But this Turing test is something that is very very widely thought of as being a good way of testing for AI, and they run now. So you can see, for example, the AISB, the Society for the Study of AI and Simulation of Behavior, run every year a challenge, a Turing test like challenge for chatbots, and you can submit your chatbot and see how it will do. It's quite a high profile event. As well as telling if we've got it, a really crucial part of AI is thinking about trustworthiness and ethics. So we have two gentlemen on the screen. One is Elon Musk, the other is the late great Stephen Hawking, and they had extremely great concerns about what AI was going to do for us. So they're not thinking necessarily about your Netflix recommender system or a Facebook. Well, they probably are thinking about a Facebook tagging system, actually. But they have great concerns about the impact that AI will have on us as a society. And their feeling is that we should be thinking now about the ethical ramifications of these technologies we're creating. And I think they're entirely correct. We are not. If you look on YouTube and search for videos of Boston Dynamics dogs walking into door frames, robotic dogs, I mean, we're not at a stage where AI is going to take over the world. But by the time we get there, it will be too late. So along with developing the cool technology, and some of my happiest when I'm building new tech and trying things out and trying out new problems, we also need to be thinking about how this is going to be used, and thinking about questions such as, can we interpret how a decision support system is making its decision? Is it biased? Do we inadvertently have a racist piece of software that's biased against certain backgrounds? We have to think about, in the driverless car sense, who's driving the car? Who's responsible if the worst does happen and someone is hit by an autonomous car? What if it makes a mistake? What about the security aspects? and the security, the ability to hack this, this is very, very important to consider. So along with thinking about the cool computing-based technology bits, we also have to think about the ethics, and that's what I'm doing with my my students at the moment, actually. So AI at Plymouth, we have a research group on AI, the Centre for Robotics and Neural Systems, and we are conducting world-leading research. It's externally assessed as being world-leading, and we're working in various areas, so machine learning, deep learning, and robotics. Optimization, so using AI and to find intelligent routes for places, intelligent solutions to problems. Computer vision, and brain-inspired computing, so designing new architectures of computers that actually are inspired by how the brain processes. And our students can work on these problems. So we have final year projects, and if a student is interested in that, then that's something that they can work on, and they can come and I've got a number of students this year working on AI problems and having a really good time doing it. So all of this is available. It's stuff that feeds into our teaching throughout the degrees. That's not worked. There we are. So AI, in conclusion, I think is not just one of the biggest parts of computing, but I think it's one of the biggest parts of society that's changing at the moment. It's driving the fourth industrial revolution. And as I've talked through, we've got lots of answers to this. You know, we've got lots of, if you think back to the slide earlier on, all the use cases on, we've got lots of ways in which AI is already affecting us. But we've got so many unanswered questions. There's so much we don't know how to do. And even within the stuff that we do know, so the computer vision, the object detection, there's so much there that we don't know. So it's a great field to be in if you're interested in pioneering how technology affects society. The ethics, we have to be socially responsible as scientists and engineers, and think about, you know, what's going to be the effect of what I'm building. It's not good enough to say, you know, I have good intentions as the creator, and it's not my fault if someone else takes it on. I think we have to have a wider view than that. So I think we have a technology here that, as long as used carefully, has great potential to help in all walks of life. And that's where I'll stop. So I have a few minutes for questions, I think.
So yes, wonderful. Please do pop any questions into the chat.
Can I see the chat?
It's been very quiet in the chat, I must admit. Yes.
That's good to hear. Thank you. When coding AI, how do you tell what it's done right and what it's done wrong? So that's a big question. There are lots of, I mean, it comes down to the sort of task you're doing, really. So we have the sort of computing approach, and we do unit testing, and we do integration testing, and testing the code to make sure that the code is actually doing what we want it to do. We also have sort of what would be in business computing called business tests, and there we're looking to see, you know, is the AI doing something that's sensible here? So if you're so I've got the slide on the screen here. If I ran this through an object detector and I got the word lighthouse, then I would have some indication that you know, my lighthouse recognition AI, which is an extremely important thing to have available to you, is working. If it says bus, then I've got a problem, because that's obviously not a bus. I don't think that there's not a bus in the picture. So one thing that you do is compare the output with known examples, and that's called supervised learning. So the idea of saying, we know what the answer is, let's see if we can predict it. And when you're doing that, you keep an element of the data back so that you're not training your model with it, your AI, and you run that through as well. So then you've got some data that wasn't used to produce your AI. If it can test that properly, then you've got something that's useful. If it can't, then you get back to the drawing board and you do it again. So quite a few questions now. What's the most popular programming language in AI? I would say Python, because I'm a biased Python programmer. People use R, people use MATLAB, Lord knows why. But no, I find Python gives you all the AI stuff, and it also is an actual proper programming language. So if you want to build it into a website or build it into a software product you're going to deploy, you can do all of that under the one roof, which I think is a good way to go. That's why I use it. Am I concerned about AI research potentially being used by dictatorships to monitor and suppress their people? Yes, I think in the way that insofar as I'm concerned about the misuse of AI generally, I think, yes, I think the one thing you should take away from this session is that I think that would be bad. AI is something that we should be using for the benefit of society. It is not something we should be using to harm people. So that's my thought there. So Lucy says, at the moment, there are lots of articles about AI taking over the world and stealing our jobs, etc., provoking a lot of public fear and doubt. How can we tackle this really negative stereotype? So I think there are two questions there. AI is not about to take over the world. Skynet is not about to deploy and take over the entire planet. However, there is a fear that people will lose their jobs. I think the important thing to recognize here is that there is a genuine risk of that, and that's something that people we have to consider, but it's not a new thing. So if you think about the Industrial Revolution in the 1700s, when people were throwing clogs into machines, that's where the phrase clogging things up comes from, because they didn't want to lose their jobs. And I think I would try and reassure people that, we've survived in the past, and I think it will survive in the future. It's a bit of a wishy-washy answer, I'm afraid. Shirley?
I wonder if I can contribute. I mean, you've quite rightly mentioned the Industrial Revolution. Think back even before that, the printing press, and fears about the technology were very much perpetuated by those who didn't want to engage with it, who didn't want to see it taking place. But all the way through, I think education combined with that sense of actually what is ethically and morally correct, and not letting it sort of run off at speed is crucial. And in terms of taking over jobs, I think if you have a job that is just repetitive and you're not using your brain to think about what it is you're doing, you're not applying knowledge, then yeah, you are likely to be replaced. So then perhaps think about the jobs that you want to head for. Think about actually not having something that can just be a tick box exercise.
Thomas says, how would ethical questions such as the greater good in self-driving cars come into play? I think various ways. I mean, we need to have, so the scenario in there is, how would you, would it be acceptable to kill a lone driver to save a large number of people in the road? And I think you probably find there aren't that many people that would buy that car, for one thing. I think it would come into play in various ways. The designers and manufacturers need to be thinking about it when they're designing how the car behaves, but also the lawmakers need to be thinking about it too, to work out how we legislate for accidents with these cars. What's the difference between artificial intelligence, machine learning, and deep learning? So it's like an onion. Artificial intelligence is the whole thing. Within that, we have machine learning, which is part of AI, but there are other bits of it. Within that, we have deep learning, which is a specific part of machine learning. Deep learning came about it was actually invented in the 80s, but it wasn't useful until the last few years because of all the data we have because of the internet. So big data has really driven deep learning, deep neural nets. I've recently seen videos of GPT-3 acting as a chatbot. It freely admits that it will lie if it's in its best interest. How concerning is this? So GPT-3 is an AI that deals with natural language and generates text. And I think it's very concerning. I think people trust what they see in the internet, and that's another whole other session, and one that I think Shirley would lead rather than me. But people have, if people are going to trust what they see, it has to be trustworthy, and I don't see a way around. I do find that concerning. What would you say common misconceptions are about AI? I think the biggest misconception is that it's done. People experience it so frequently in their lives that it's not, we sort of assume that it's done, and I sort of assume bits of it are done when I'm not in work mode, and it's often horrifying how undone it is. And when you look at how some of it's working, we're not there yet. Have I ever played AI Dungeon? I'm afraid I haven't. Have I seen any of Code Bullet's videos? No, I'm afraid I also haven't. So Varish says, what's what's the difference between strong AI and weak AI? So strong AI is an artificial intelligence that sort of cobbles everything together and is believable as a person. It's got lots of different facets to it, and it's working towards general artificial intelligence. It's sort of the holy grail. Weak AI is having an optimization algorithm that solves route finding problems, or having a recommender system built into a social media platform. It's a specific tool, does a certain thing, usually does it very well, and but it's, I mean, if I have an optimization algorithm that I've been working on in the last couple of days, it designs water pipe networks. It's never going to compose music. It's never going to look at the field of view in front of me and tell me what's there. It's doing a very specific job. So that's the difference. You've also asked, what is an artificial neural network and how effective is it? So a neural network is basically a computational model that's used to predict things, and you pass inputs in. And it might be an image, so you might give it raw pixel values. It processes those pixel values, and then out comes an answer. So in the case of doing object recognition on the slide here, we'd pass in the, I don't know, 1024 by 768 pixels that I have on my screen, and out would come the answer lighthouse. In between is a black box, and it's processing the data. It's processing those pixels. It's extracting features from the image. So it might be doing edge detection, for example, and it's going to produce an answer that we hope is lighthouse, but may be bus. So there we are. So a question from Shirley: why do some people trust technology more than they trust humans, given that humans create the technology? I'll answer that if I can. I don't. So for many years, I didn't have internet banking, and I was asked once by a bank manager in a session. He said, "What's your job?" And I said, "I'm a software engineer." I was at the time working as a commercial software engineer. He said, "Okay, and why don't you have internet banking?" I said, "Well, because I'm a software engineer, and the thought that someone else has written this software like me was too horrifying." This was about 15 years ago now, but that's my answer. What do other people think?
I mean, for me, it was triggered by, I think Ben asked that question about the chatbot, and freely admitting it would lie in its best interest. I know a whole load of people like that.
Yeah.
So why would a chatbot be any different from some of the people you have to deal with? So I think,
there's an argument there, actually. If we want to create something that's like us, it has to be able to do the things that we probably shouldn't be doing.
Yes.
The question, I think, is that what we want? Do we want to be targeting it for that, and should we be? But
and whose moral code do you follow?
Well, that's the question.
There are different moral codes.
So we talked last week in a session on this with our students about having laws and how you might have bias coming from certain countries. And I made the statement, well, why don't you think about having a data set that's based on the entire world? And one of the students pointed out that that's not going to work at all, because you have, the different law sets would be so it would be so unapplicable to certain countries that it just wouldn't work at all. So I think this is a general computing thing, isn't it? Before you start coding, before you pick up the keyboard, you have to know exactly what you're doing. And this is a computing design problem, like any other, I think, in some ways.
Yes. I mean, certainly as a Western woman, a woman brought up in the UK, I would probably be very concerned if the moral framework or the legal framework that was then going to influence my life was then coming perhaps from a country where I wouldn't want to live.
Yeah. And people in that country would be as horrified if the reverse happened.
Exactly.
And that's the problem, isn't it? You can't have there's not a one size fits all solution to the problem. Wow, that's a question.
We are about to run out of time, though.
Yes. If machines permitted. I think that's a bigger question than we have time available, I'm afraid.
Yes. Yes.
Apologies. But yes,
right.
Thank you.
So yes, thank you ever so much, David, for as normal, and very informative, entertaining talk, which yes, generates some serious thinking about.
It's a topical conversation.
It is. And thank you to those of you who have attended. I hope you've enjoyed today's session. The recordings will be going out later. They'll be shared via the CAS community, and people who have registered their attendance here will be getting those links. So yes, thank you everybody.
Thanks very much. Enjoy the rest of your day.